Hi everyone, today we are going to talk about interpolation search. Before we're talking about it, let's first understand the definition of the interpolation search. It means finding a particular item by computing the probe position. In other words, it means decreasing the search range so it's quicker and convenient for us to find our target item. For example, we have the book indexing or dictionary. Let's suppose we are going to find an item that starts with the letter A. So you just ignore other things and go directly and look whatever you want to look at. This is what we define algorithm called interpolation search. Interpolation search is also defined the probe position, which means the position of the middlemost item of the collection. This definition sounds a little bit harder to understand, but don't worry, we have the formula to calculate the middle index. This is the formula and that you want to grab when you do interpolation search. But don't worry about each symbol means. Right now, we will give you an example that will help you understand what kind of value that you put in each symbol. So before we're talking about the real world example, we want to first start on our abstract algorithm. For example, suppose we have the abstract algorithm has three parts. The first part is if the middle item is less than the item that we want to search on. Then the probe position is again calculated in the subarray to the right of the middle item. Otherwise, the item is searched in the subarray to the left of the middle item. This process continues on the subarray as well until the size of the subarray reduces to 0, which means that you found the item that you really want to search on. So, for example, let's suppose we have the order array from small to large like this. And we want to find the number 11. And we'll use the formula that we talked about before and calculate the middle index is equal to 9, which means we should start our probe position on 9. And since 9 is less than 11, so that means the probe position starts from 9 to the right. And we do not need to consider the 1 and 7 because that's kind of the spaces, the unnecessary spaces that we don't want to spend most of the time on that. And I can actually summarize the abstract algorithm, convert into the steps algorithm. This is kind of thing that you really want to follow when you do the interpolation search. So the step 1, start searching the data from middle of the list. Step 2, if it's a match, return the index of item exists. We're happy about that. But most of them we have to continue on. So we do the step 3. If it is not a match, we calculate the probe position. And step 4, divide the list using the probing formula and find the new middle index. Step 4, if data is greater than the middle, then we search in the higher sublist. If the data is smaller than the middle, we search in the lower sublist. And we repeat until we find the item we really want to find. And then we can use this step algorithm to transport into algorithm pseudocode. We can actually go to this pseudocode real quick because it actually converts the step algorithm in another way, but the concept is the same. So the A means array list, and N is the size of the array, and X is the target value that we want to search on. So this is the procedure interpolation search function startup. So we set the lowest index to 0, we set the middle is -1, we set the highest index is the size of the array -1. So we want to do the while loop. So while x does not match. If the lowest index equals to the highest index or the value under the lowest index equals to the value under the highest index, then we exit the loop because it's fair. We could not ever find our target. And then we go to the middle function formula and we want to compare the middle index to the item that we want to find out. So if the middle index is equal to the target value, then we exit. So actually we actually found it. Exit the loop. Otherwise, if it's not equal, we have to do comparison continue on. If the middle index is less than the x, we set the no index to the middle +1. Otherwise, if the middle index is larger than the x, then we set high to the middle -1. And then we end the while loop, we end the function. And then I search on the internet, it's a big old runtime of the algorithm. The runtime of the interpolation sort is a big O N. For example, if you want to search for 1001, 2, 3, 4 to all the way to the 999 to 1000, it's gonna take you 10 to the 9 times to find the 1000 that you really want to find out. But this is now we want to spend most of time, and you just like understand that this is gonna take you a while to find the items. And what we want to spend most of time on that is a dynamic example. So here's a that I come up to help you understand interpolation search and how we actually do this search. Let's suppose we have the array of all this number, and we try to find the 1166. And we will only look at the propagation from 1144 to 116 to 1188. We were now looking at any other spaces since the numbers start with 11. And how we can do this, how we can calculate this kind of propagation. First, we need to using this formula to find the 1144. How we can find the 1144? Let's start with all the symbol and how we can put the value. So L, lowest index 0, highest index plus highest index 8 minus the low index 0, divided the value under the highest index is 3399 minus the value under the lower index is 0011 times the item that we want to search on is 1166 minus the value that under the lower index is 0011. And you do this calculation by yourself, and you found in the item is 1144. And this result is where you want to search by. You define your search space, and then you have to do this formula over and over again until you finding the item that you really want to find out. Or you can do another way. You can use this interpolation search to find this kind of section that you want to start your search from, and then you can use a binary search to search the 1166, this number. So I hope everybody understand the interpolation search, and thank you for your listening today.